So this is the second part of the Unit 1 test review. Remember to make sure you have anything that you need to write with, whether it's pen, pencil, anything and something to write on, okay? Also, make sure to pause every time that you have to write out a problem or word problem. That way you can go ahead and get that done, all right? So let's begin. We're going to go ahead and we're going to start with another word problem. Now we're going to work into word problems and translating into systems of inequalities, okay? So, Sarah started a new job sewing cloth face masks to help earn money to pay for her $75 cell phone bill. She is selling the adult size for $5 each and the kid size for $3 each. She knows she has enough cloth material to make 25 masks. Luckily, she already has at least 2 adults interested in placing an order. Write a system of inequalities to help Sarah determine how many adult and kid-size masks she should make. So now with code, we need to circle all our numbers. I've got 75 right here. I've got $5 each, $3 each. She's got to make 25 masks. She has at least 2 adults interested. We want to go ahead and we want to write a system of inequalities for this scenario, okay? Now let's go ahead and let's box in our keywords, okay? If I'm looking here, I know she wants to earn money to pay for her $75 cell phone bill. She's selling the adult size of the masks, and she's got the kid size of masks. So we know, since we're working with systems, we're going to have to label. So let's go ahead and make our adult size the X, and let's make our kid size the Y. Alright, those are the 2 variables we are going to use here. She knows she has enough material to make 25 masks. So she has enough to make a total of 25. That means I must have X plus Y is less than or equal to 25. Now, the reason I put less than or equal to is because of this word right here, enough. And enough, she's saying that she has just enough to make 25. So she can make less than 25 or equal to 25. So that's why we had that, all right? Now, we look at the first sentence where it says she has to get $75 for her cell phone, all right? She has to earn money to pay for her $75 cell phone bill. She's going to sell the adult masks, which we said was X, for $5 each. And then she's going to sell the kids' masks, which are $3 each. And again, each means to multiply, which is why we're combining them and attaching them to our variables. Since this has to do with money, we're going to combine it with the money that we're given here as well, as when you look at that $75. Now, if her cell phone bill costs $75, we know that she has to make at the least $75. She cannot make $70 because that means she's still going to owe for her cell phone bill. So we know she needs to make at the least $75, which would be greater than or equal to 75. And then where it says, luckily she has at least 2 adults interested in placing an order. So we know that the adult masks that will be sold are going to be at the least, again, at least is greater than or equal to 2. So this is your system of inequalities right here. This whole scenario gives you these 3 equations for this system of inequalities, all right? If you want to, go ahead and feel free to go back to the beginning and start this over again if you want to, or start it all over and do it on your own first before going back through it, okay? Now, we got another example right here. And if you'd like to write it out, solve it on your own first, or let's go ahead and do it together. So Sarah's selling bracelets and earrings to make money for summer vacation. The bracelets cost $2 and earrings cost $3. She needs to make at least $500. Sarah knows that she will sell more than 50 bracelets. Write the system of inequalities to represent this system. So, let's use Cub, circle my numbers of $2 and $3. $500. So there you go, money, money, and money. We know we're gonna have to put that together. Then we got 50 bracelets. I'm gonna write the system of inequality to represent this information now. So Sarah is selling bracelets and earrings. Again, we know we're working with systems, so we're gonna go ahead and have to label. Let's go ahead and make my bracelets X and my earrings Y, okay? She's selling them to make money for summer vacation. The bracelets, which is our X, cost $2. So that cost is like saying per or each. They each cost $2 and the earrings each cost $3. She needs to make at the least, well, we just went over at the least on the last one, and at the least means you can get that amount or more. So we know that is going to be greater than or equal to. So we need to sell the amount of bracelets times 2 plus the amount of earrings times 3, which is what they cost, has to be at the least $500. Sarah knows that she will sell more than is like saying greater than 50 bracelets. So we said bracelets was our X value, so she's going to sell X is greater than 50. She knows that she will sell X greater than 50, meaning more than 50 bracelets. So, again, if you need to, go ahead and go back and let's solve this one all over again on your own if you'd like, okay? If not, let's go ahead and let's move on. So right here, I'm being asked to graph the system of inequalities. So let's go ahead and let's do this. We know, though, that if I use a system, if I'm graphing systems of inequalities, the easiest thing for me to do when graphing is to put them into slope-intercept form. These are not in slope-intercept form. For those of us that forgot what slope-intercept form is, again, that is when it is in the form of y equals mx plus b. So what I'm going to do is I'm going to put these into slope-intercept form. The first one is 3x plus 2y is greater than or equal to negative 2. Now, whenever we're putting in a slope-intercept form, we want to solve for y. Got it? So I'm going to move that 3x over by subtracting it. And I've got 2y is greater than or equal to negative 3x minus 2. I'm going to divide by 2 to get that y by itself. And I've got y is greater than or equal to negative 3 over 2x. Negative 2 divided by 2 is negative 1, so minus 1. So that's my first equation I'm going to graph. Let's go ahead and let's turn the other one into slope-intercept form as well. So I've got x plus 2, y is less than or equal to 2. Got to move that x over, minus x minus x. 2y is less than or equal to negative x plus 2, and let's divide by 2 now to get that y by itself. Y is less than or equal to negative 1 over 2x plus 1. So, let's graph that first equation right there. In that first equation, we're going to use our y-intercept, which is negative 1, and we're going to start with that. Then I'm going to use negative 3 over 2, which is my slope, to graph my other points. So negative means I got to go up and to the left, so I'm going to go up 3 because it's rise over run. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I ran out of space, so now I can go down. 1, 2, 3, 1, 2, and to the right. Okay? Now, if I want to graph this line, I notice I have to look at my inequality. Well, my inequality says greater than or equal to. That equal to tells me that I need to draw a solid line. So let's draw that solid line from this point to that point. Now, the greater than tells me all my y's greater than. That's what has to go shaded in. So let's shade that area in, okay? I'm going to shade this area in. And there we go. Now, let's graph our next equation. I'm going to use a different color for that one. I know my y-intercept is plus 1, so I'm going to start at 1 on my y-axis, and it's negative 1 over 2. So again, I'm going up and to the left, so I'm going to go up 1, left 2, up 1, left 2. I'm running out of space, so now let's go down 1 and 2 to the right, down 1, 2 to the right. And again, look at the inequality here. The inequality is less than or equal to. Since it's less than or equal to, again, that is also a solid line, so I'm going to draw a solid line. Now it's less than, so it is all the numbers less than y, so I'm going to shade in everything less than y. Now, to get our solutions, we know that our solutions would be everything inside the double color area or double shaded area, which is going to be this area right here. Everything in here, and again, since they are all equal to, it is everything on the lines as well. All right. So if you'd like to start all over again, you're more than welcome to. If not, let's go ahead and move on to the next one, all right? So right here we've got another system. And again, we know that if we want to graph an equation, we need to put into slope-intercept form. Again, slope-intercept form is in the form y equals mx plus b. So that first equation is not in slope-intercept form. So let's go ahead and let's change it. Got 4x plus y is less than 2. I'm going to subtract that 4x because we know we want to get that y by itself. What I do to one side, do to the other side. Y is less than negative 4x plus 2. The other one is already in slope-intercept form, so let's go ahead and plot this first one now. Again, I'm going to use that positive 2 as for my y-intercept. That's the first thing I always plot, my y-intercept. And then my slope is negative 4. So rise over run tells me negative 4 over 1. So I'm going to go up 4 and 1 to the left. If I go up 4, I'll run out of space. And it should be around right there. So now let's go down 4. 4, 1 to the right. Down 4. And to the right. And I'd run out of space there as well. Now what we do notice here is that it's just, the inequality is just less than, all right? The inequality is just less than. So what I'm going to do is I'm not going to do a solid line now. I'm going to do a dashed line. I'm going to do a dashed line now. And there we go. Now, it says less than, so I need to shade in all the y values less than this equation. So it's all the y values less than, so I'm going to shade in all this area right here. Now let's go ahead and graph the second one. Again, I'm going to change the color for that second inequality. And it's y is greater than negative 2. Well, all we got is a negative 2. So what I'm going to do is I'm going to go to my y at negative 2. There is no slope, so all I'm going to have is a line. But again, if you look at your inequality, it's just greater than, so it's going to be a dashed line. So I'm going to put a dashed line. The inequality says greater than, so I'm going to shade in all the values greater than for those y's. So these are all the values greater than negative 2. And let me go ahead and shade in the area that would be or would hold all of our solutions now. Now, on the last one, everything we shaded in was a solution as well as everything that fell on the line. If any points on these lines, however, would not be solutions because they are dashed lines, so it has to be within the shaded area only, not on the line. All right? If you'd like to start this all over again, go ahead and do so. If not, we can move on to the very next one, okay? That's right here. We got a system of 3 inequalities. We do notice that they are all in slope-intercept form. So the first one is go ahead and let's graph that one now. And the first one is y is less than or equal to negative 1 over 3x plus 7. I'm going to use this plus 7, which is my y-intercept, and I'm going to plot that first. Then I'm going to use my slope, which is -1/3, to plot the rest of my points. -1/3 tells me, since it's negative, I'm going to go up and to the left. So I'm going to go up 1 and 3 left. Up 1, 3 to the left. Up 1, 3 to the left. And I've run out of space, so now I can go the other way. So down and to the right, down 1, 3 right. Down 1, 3 to the right. So if you look at your inequality says less than or equal to. That equal to tells me that I have to put in a solid line. So I'm going to put a solid line now, all right? So let's draw this line. There we go. Since it says less than, we're going to shade in all the y values less than that. So let's go ahead and shade in all those values less than. There we go. Now let's look at the second equation, which reads y is greater than 2/3x minus 5. I'm going to change my color for this one. And I'm going to start at -5 on the y-axis because that is my y-intercept. I'm going to use 2/3 for my slope, which is rise over run. Since it's positive, I'm going to go up and to the right. So 2 up, 1, 2, 3 to the right. 2 up, 3 to the right. I ran out of space. I can go down and to the left. Now, we notice here that the inequality is just greater than. There is no equal to, so I'm going to draw a dashed line. Draw a dashed line. There's your dashed line. It says greater than, so let's go ahead and let's shade in all the y values greater than this equation right here, than this line. So let's shade all that in. And then we got one more that just says x is greater than -3. So let me change that color as well. X is greater than -3. So I'm going to go to my, since it's x, I'm going to my x-axis, and I'm going to -3. And that's where I'm going to start my line. Again, the inequality is just greater than, not equal to, so I'm going to draw a dashed line. All the way down. Now it says greater than, so all the x values greater than -3 are all these values on the right side. So I'm going to shade that in as well. Okay? Now, we know that all our solutions are going to be within the triple now color area. So the triple shaded area, and I will try and get that for you right here. And it is all this area in here. Now, notice, if there is a point on the yellow line, that is not a solution because it is not greater than or equal to, it's just greater than. If there is a point on the blue line, again, it is not a solution because it is not equal to. The only time it will be a solution if it's on a line is if it is on that red line for that first equation, because that red line is a solid line and it says less than or equal to. So it can be equal to that one as well. If you'd like to, go ahead and start this one all over again. If not, then let's go ahead and let's move on. So I got another systems of 3 inequalities right here. Luckily, they're all in slope-intercept form as well. So let's go ahead and let's plot the first one. First one reads y is less than 3x minus 4. So I'm going to start at that y-intercept, which is -4. I'm going to use that 3 as for my slope. And again, 3 over 1, which is rise over run. I'm going to go up 3, 1 to the right, up 3, to the right, up 3, right, up 3 to the right. I'm running out of space there, so I'm going to go down and to the left, down and to the left. Now it says just greater, less than. There's no equal sign, so my line is going to be a dashed line. All right? Just a dashed line. There we go. So now I'm going to go ahead and I'm going to look at my inequality, and it says less than. So I need to shade all the y values less than this equation. So it's all these y values here, and I shade this side of my line. All right? Now let's take a look at the next equation. The next equation says x is less than or equal to 5. Since it's just x is less than or equal to 5, I'm going to go to 5 on the x-axis and put my point there. Now notice it's equal to, so I'm going to draw a solid line. And it's less than, so all the values less than 5 are all these numbers on the left side. So I'm going to shade in all these values on the left side. All this side of the graph right there. Okay? Now let's look at our last one. And our last one says y is greater than -2. So it's just y, -2. I'm going to go to -2 on my y-axis. And notice that it just says greater than. So my line has to be a dashed line because it's not equal to. So I'm going to draw a dashed line. And again, it says greater than. So we're going to shade all the numbers greater than -2. So I'm going to shade on the top because all these y values are greater than -2. So if we look in here, all our solutions are going to be within the triple shaded area or the triple color area. And let's see if I can get that for you. I would do my best to go ahead and get that, and it looks right. There, all the solutions that fall in here will work out. Now remember, the only line that it could be on as far as the point in order for it to be a solution can be that green line only, because that is the only one, that is the only equality that is less than or equal to. So if it follows on a solid line, it is our solution. If it falls on a dashed line, it cannot be a solution, all right? So if you need to, go ahead and go back to the beginning of this. If not, you can go ahead and let's move on. So right here it says, is -4, 0, -2, and or 4, 2, -2 a solution to the system below? So the easiest thing for me to do here is to substitute. It really is. And I'm going to substitute these numbers in place of x, y, and z, because again, we know that's x, that's y, that's z. This should be x, y, and z as well, okay? Now, the first equation says 4x plus 4y plus z is less than 24. Well, let's see if that's true for both of these, okay? So instead of x, I'm going to go ahead and put -4 plus 4. Again, instead of y, it's a 0. And instead of plus z, I'm going to put -2. And I'm going to see what that equals to. And when I plug it into my calculator, that is going to equal to -18. Now, this one is actually true because -18 is less than 24. So let's use the next one. And I'm going to use different color for the other one. And I've got 4. Again, instead of x, this one says 4 plus 4. Instead of y, it's 2 plus z, again, is -2. And when I plug that into my calculator, I get 22. So that statement is true. Remember, they all have to be true in order for it to be a solution, all right? So, let's move on to the next inequality that we have. The next one reads 2x minus 4y plus z is less than 0. So I'm going to substitute, again, 2. Instead of x, it's -4 minus 4, again, times 0 instead of y. Then plus z, instead of that, I'm going to put -2. Now when I plug that into my calculator, I get negative 10. Again, it's supposed to be less than 0. This is negative 10. Negative 10 is less than 0, so that is true. So let's move on to the next solutions they gave us. And I've got 2. Instead of x, we're going to put 4 times 4 minus 4. Instead of y, I'm going to put 2. And then plus z. Instead of plus z, I'm going to put minus 2. And when I plug that into the calculator, that gives me negative 2. So we know it has to be less than 0. Well, negative 2 is less than 0, so that is a true statement as well. So that solution is good as well. So now let's check out the last one. See if the last one works out. So I've got negative 2x plus 5y plus 2z is less than or equal to 4. So in order for it to work out, it either has to be less than 4 or equal to 4. So I've got negative 2. Then instead of x, we've got negative 4 plus 5. And that's a 0, plus 2, instead of z, we've got negative 2. And when I plug that into my calculator, I get 4. So if you look here, it says less than or equal to 4. Well, 4 is 4. 4 is equal to 4. So this is true as well. So we know that that first set of solutions, negative 4, 0, and negative 2, are going to be true. Let's go ahead and let's finish the last one now. Again, I've got negative 2. Instead of x, I'm going to put 4 plus 5. Instead of y, I'm going to put 2 plus 2. Instead of times z, I'm going to put times negative 2. And when I plug that into my calculator, I get negative 2. So, negative 2 is indeed less than 4. So that is true as well. So we know that both sets of solutions are indeed true and they are solutions. So this is a yes and this is a yes. Again, we just did this by simply substituting. If you need to, go ahead and start all over. If not, good job. We're now done with this review. Good luck on your test, everybody.